This recording is with regards to number 11 in the Math 313 practice quiz. It reads, owners of a car rental company have determined that if they charge customers P dollars per day to rent a car, where P now is between 60 and 300, okay, the number of cars N they rent per day can be modeled by the linear function N of P is equal to 3,150 minus 12P. If they charge $60 per day or less, they will rent all their cars. If they charge $300 per day or more, they will not rent any cars. Assuming the owners plan to charge customers between $60 per day and $300 per day to rent a car, how much should they charge to maximize their revenue? So to get assistance for such a question, let's see where we can go. We can go to question 45 on page 69 in the electronic whiteboard. Let's go there. And here you have an example of such a question. So as you can see, it is similar to question number 11. It says owners of a car rental company have determined that if they charge customers P dollars per day to rent a car, where P now is between 60 and 300, the number of cars N they rent per day can be modeled by the linear function N of P is equal to 1,050 minus 7P. Quite similar. If they charge $60 per day or less, they will rent their cars, all their cars. If they charge $300 per more, they will not rent any cars. Assuming the owners plan to charge customers between $60 and $300 per day to rent a car, how much should they charge? So this is a case of maximization of their revenue. Okay, so let's see how we can solve such a question. And here it is preferable to go through the steps that we looked overview with the AI overview. Let's take a look at the AI overview. So as you can see, the number of cars rented per day is N of P is equal to 1050 minus 7P, just like our example, 1050 minus 7P. Okay, so here you've got the revenue, the number of cars rented per day function. Now, it says helpful information. Revenue is calculated as price times number of cars, okay? The number of cars is a function. So to find the maximum of a quadratic function, find the vertex. The x-coordinate of the vertex of the parabola is given by minus 2 minus b over 2a and so forth. How to solve? So first we have to define the revenue function. So this is important. What I just read there is not so relevant. So just ignore this for now. That helpful information, that's just extra information. So focus on step 1. To multiply P, the price, by the number of cars rented, which is an expression. So P times 1050 minus 7P, that's 1050P minus 7P squared. So you have the revenue function. So now you have to find the price that maximizes revenue. So how do you do that? You, well, this is a different approach. The approach we normally take is optimization using differential. So let us verify. Right, so here you have the same example. Right, so that's another approach, which of course, that's the approach we expect to do it. You find the revenue function and you find the maximum of a revenue function. Its critical point by setting its derivative to 0. So we have to apply derivatives. So first, you find the revenue function. Multiply P by the number of cars sold, the quantity function. And here you have 1050 P minus 7P squared. Now, step 2, find the derivative of the revenue function. So you find dr dp. So you dr dp, here P, you apply the power rule. Power is 1. 1 times 1050 is 1050. P to the 1 minus 1 is 0. So the P simplifies. P to the 0 simplifies to 1. 2 times negative 7 is negative 14, and 2 minus 1 is 1. So here you have the revenue, the rate of change function, the derivative. Okay. Then you have to set this derivative equal to 0. Yeah. And then you solve for P. So 1050 minus 14P is equal to 0. 1050 is equal to 14P. You divide by 14, and you have the price that will maximize the revenue. And to get the to check to see if this is within the range of 60 and 300. 75 is between 60 and 300. So we okay here. And to verify that the critical point is a maximum, you substitute. You can apply the second derivative function, or you can substitute 60, 75, and 300, and 75 will give you the most. Okay? Or you can apply the second derivative function. Since the second derivative is a negative, that means you have a maximum. Second derivative means that you simply differentiate again. So 1050 goes to 0, and negative 14 simplifies. Negative 14P simplifies to negative 14, and since you have a negative, then you have a maximum. We call it the second differential test. Or you can substitute 60 into the revenue function, substitute 75 into the revenue function, substitute 300 into the revenue function, and you will see that 75 will give you the most. So let's see how this was done here. Here you have the number of cars, the quantity function, the number of cars function. You multiply P, the price, by the number of cars function to get revenue function. Here you have it, P times 3150 minus 12P in a bracket. Then you have 3150P minus 12P squared. Then you find the derivative of the revenue function, drdp. 3150P, which simplifies to 3150 because P to the 1 minus 1 is P to the 0. P to the 0 simplifies to 1. 2 times 12 is negative. 2 times negative 12 is negative 24. And 2 minus 1 is P. So here you have the rate of change of the revenue function, the RDP. Now you equate this to 0 and you solve for P. 3150 minus 24P is equal to 0. Then you simply cancels on one side and you divide by 24 to get a price of 141. So what is needed now is to apply the second differential test. If you differentiate again, you're going to get negative 24 because 3150 going to simplify to 0, that's a constant, and minus 24P turns to minus 24 when you differentiate again. And since you have a negative 24, that's a maximum. Or you can apply, substitute 60, substitute 141.25, and substitute 300, and you will see that 141.25 gives you the maximum profit. Let's do that. So I'm going to substitute 60 into the revenue function. Remember, the revenue function is 3150P minus 12P squared, 3150P minus 12P squared. So we have 3150 times 60, subtract 12 times 60 raised up to the power of 2. $145,800. Okay, that's for 60. Let's try 141.25. So we have 3,150 times 141.25 minus 12 times 141.25. 0.25 raised up to the power of 2. 206,000. That's clearly is more. And let's verify. Well, 300. So you have 3,150 times $300. Subtract 12 times 300 raised up to the power of 2. And you can clearly see it has decreased. So $141.25 will give you the maximum revenue. So this is correct.